Okay, so now we're going to talk about scaling of Kubernetes deployments, scaling of apps that are considered, that are deployed on the Kubernetes platform. Okay, so before we get into that, I think the important concept here to understand is why is it a good idea to do scaling? Well, if you develop an application, let's say if you have an idea and you create a prototype for it, and that idea gets really popular, then you will most likely get a lot more users almost unexpectedly at the time you're not expecting it. And if your system is not ready to handle it, then it may not be the best thing for your startup or other initiatives. So one example that may also drive this point home is the idea of in the US at least, there was recently in this year 2021 this concept of sign up to come and get the vaccine shot. And a lot of sites where people were signing up, the sign up would open at a certain time in the day, and everybody would go and log in. And what happened, most people would just sit there and stare and stare and stare, and the spinner on the page would just spin, and what would happen is basically a good portion of the users just would get an error, or they would say, hey, we can't service your call right now. Actually, if you Google for the word, let me see if I can show you this thing. So if you Google for the word Twitter whale, it used to be a thing that Twitter would show people when it could not handle the traffic. And I'm trying to bring up my Firefox here. In the meanwhile, while that starts up, I'm going to show you how Kubernetes deployments are scaled. So right now, the first thing is we're just going to go ahead and check all the pods that we have. And to get all the pods across all namespaces, I'm just doing kc pod get get all namespaces. Right. So then this command kc is my short form for Kubernetes, because I don't kube control. I don't like to type the whole thing. So whoops, that's more larger than what I wanted it to be. Let me see if I can just decrease the font a little bit so it'll fit in. Okay, I think this much is probably readable and good. Okay, so I said Kubernetes control kubectl, please go ahead and give me all the pods, and it is showing me all the pods I have. And notice that they are in any and all namespaces, right? So it's showing me the internal kube system pods, the pods that Kubernetes is running to do its own job, as well as pods that are deployed as applications. Right now we don't have a custom namespace, so this is our pod that we have. And what I wanted to show you is if you take this deployment, right, and scale it, you can increase the number of pods that are running, and it's very easy. So the command for that is kubectl scale deployment, and the name of your deployment, which is in my case is deploy example, and then you take the replicas equals, and then you give it some number x, right? So the scaling of a deployment, to get more pods running for your application, you type in kubectl scale deployment, give it the name of the deployment that you created. In our case, that is deploy example. That's the name of the deployment object. That's not the name of the pod, by the way. That's the name of the deployment object. And then you give it a -- replicas equals to some number. So if I type in 4 here, you will see that Kubernetes will say, okay, fine, I'll scale your applications, right? And, now if I just say kc get pods, all of them, but if I want to grep for just the ones that start with deploy example, you'll see that instead of 2, I've got 4. Why do I have 4? Because I told Kubernetes right over here, hey, I would like to have 4 copies, 4 replicas of my deployment, and my deployment creates this pod deploy example. Okay, and they're all running. As you can see, the 2 pods have been running for 12 hours because I think I created them yesterday. And these 2 I just created in front of you. So the life time for them is 15 seconds, right? So I can scale them up, and you can, if I had supplied any other number, it would, match it. Note that I can also go back down. So if I can rerun the command, I can say, hey, I only want 1. Okay. And if I do that, then the action that it takes is basically terminating some of the pods that are already there, right? So if you remember, Kubernetes has the, you see this pod is now terminating. It's no longer needed. So Kubernetes has a controller, whose sole job is to basically look at the state of the cluster and always be comparing the desired state with the current state. That's basically the job of Kubernetes, right? So what is the desired state? Desired state is what you tell Kubernetes to do. Say, hey, I would like to have 10 pods of my application, or I would like to have 2 pods of my application. And the current state is what already it's running on the number of nodes that you have in your cluster, right? So if you're running 2 copies of your application, but you want 10 copies, then it knows that it needs to create 10 new ones. So it'll schedule. Sorry, if you want 10 copies of your application, but you have 2, then it knows that it needs to create 8 new ones. If you have, let's say, 10 running and you want 5, then it knows that it needs to terminate some pods. So the summary of this is that Kubernetes will scale things up or down depending on the number of replicas that you tell it to create. So if you tell it to create, right now, let's say I only have, let's just see this. So right now I only have 1 pod, okay? If I tell Kubernetes, hey, I would like to just have 1 replica, right? Okay. And I go back and see it again, I still have 1. The thing is that Kubernetes did its thing in the background and said, oh, he wants 1 copy of his application running, okay? 1 pod running of deploy example. And right now I see that on our nodes, which in my case is the same machine where I'm running everything, is also just 1 copy. So it says, okay, fine, there's nothing for me to do here, okay? But if I had supplied a number higher than the current state or lower than the current state, then it takes the corrective action. And in the case of scale deployment, that corrective action could be spinning up new pods, or it could be terminating new pods. It can go either way. That's the key thing to understand, okay? So now, the way I want to explain and show you how this thing actually really helps is I'm going to show you where this scale deployment is not just a nice to have, it's almost like a must have, okay? And in order to do that, we need to send some traffic to our pods and see, what they're doing, right? And there are a few things I want you to first understand. Your pods have a given amount of CPU and memory that is allocated to them, and you can kind of see this in multiple ways, right? One way you can see this is you can say kubectl top pod, and then you can give it the name of your pod. It's just running the top command on that pod, and that'll show you what the CPU the pod is currently using in increments of millis, and memory in what is this called? I need to check on that. It's not megabytes. Okay. Okay, so right now the pod is using very little memory and almost no CPU because, we're not hitting it with any traffic. And so in the past, we've talked about, just the concept of this service. So if I say this, if I ask Kubernetes to give me the list of all the services we have, this is how we were hitting it. We were hitting it with a cluster IP type service, and if I curl it on this, if I send it a web request, which is what curl does, right? So if I say curl HTTP 10.43.60 3.24, it gives me the Nginx welcome to Nginx page. Okay, now it gives me the welcome to, but the thing is that what I want to do now is I want to run a load test using a load testing tool, and I want to hit this service, this set of pods with tons of traffic. Like I want to simulate hundreds and hundreds of users coming to our website, okay, which is served by this set of pods, that Nginx pods. Okay, so in order to do that, the first thing that we need to do is I'm going to basically use Apache Jmeter, and you can download it. Okay, so you can, Apache Jmeter is one of the load testing tools. There are several others here. Right, so the ones that I've used or I'm familiar with are basically Apache Jmeter, and there's also something called Apache Bench that you can use. If you look at Apache Bench, you might be able to just simply show a simply provide an AB command, and it'll simulate a set of users, a large number of users coming to your site. Okay, there's also something called Locust that I've heard people talk a lot about. I believe that is Scala driven. Let me see, is that the same thing, or is that no? Locust load testing. Okay. I'm going to have to check this out. I think, how do you test this? Is this the one that works with Scala, or is that Gatling? This is Python driven. So if you want to write code, and if you're okay with writing code to do this, then you can use this tool, which will give you essentially the same effect. You can say, well, I want this number of users to come on my site, and I want them to request this URL. Okay, so you can do that. The last one I'll show you before we get going here is called Gatling. That's also one of the main open source load testing tools. Okay, and I think this is the one where you write Scala code in order to pull this off. Okay, let me see if I can see it. Okay, you see these? This is a Scala-based class. You have to write Scala code, and you provided the URL that you want to hit, some of the headers that you want your request to have, and then you say, hey, go ahead and execute the scenario, and it does that for you. Okay, but the one that I am most familiar with, and the ones that we are going to be using, is called Jmeter. So let me create the Jmeter. Let me spin up Jmeter here. Okay, give me just 1 second. Okay, so this is the screen for Jmeter. So the one thing I'd like you to note is that I have installed the plugin manager, and in the plugin manager, I have this window that comes up here, and I've installed something called custom thread groups. Okay, so if you get Jmeter, and if you decide to use Jmeter to run this test, then I'd like you to first install the plugins manager, because that it itself, I think, is a plugin. And then once you have the plugin manager, which gives you the GUI experience, you can you should get like this custom thread groups plugin, okay, because that's the one I'm using. And I'm going to show you what is it that I'm doing here with this thing. So I've developed myself a test plan. And what is it that I'm trying to do? I'm trying to send a bunch of traffic to the to the pods that I've deployed on Kubernetes. And why do I want to do that? Well, I want to stress test it. I want to load test it to see when hundreds of users would come and use our application, would it stand the test of stress? Like, would the application crash, or would it continue performing in a good way, right, in a satisfactory way? And so in order to do that, I am using this concurrency thread group, which essentially allows me to create a step stepwise increase in the number of concurrent users, right? So what you see here in this red chart is a set of users that are coming in and are using requesting the web page. The web page is just the home page of Nginx. There's nothing really running in our pod other than a bare bones Nginx server, right? And this test is just requesting the home page. Okay, so there's no actual real web app being served. But just to get the point across, the thread group that we're using is allowing me to set the total concurrency. That's the maximum concurrency that we get out of here, get in this test. And I'm saying, hey, I want to go from 0 to 800 in 5 steps. Okay, sorry, I take that back. Well, no. I think that's good, but I think the box that I'm on, I made a small mistake. So I'm saying that within every time you go up and take a step up, I want that to happen in half a minute. So that's about 30 seconds. Let me think about it. It should be 30 seconds, but I don't see this adding up to 30 seconds. And that's also not 30 seconds. Anyway, maybe I don't understand how this piece of it works, but ramp up steps count is 5. That's basically saying I want to get to my maximum concurrency in 5 steps. Okay, I want to get to my maximum concurrent number of users in 5 steps. So you see 1, 2, 3, 4, 5 steps. And I want to, once I get to the top, once I get to the highest concurrency that I want in this test, right, I want to simulate 800 users using this application all at once. That's what I'm trying to do. So once we get to the 800 threads, right, I want to stay there. I want the test to just continue creating enough threads and maintaining those threads so that I would have 800 concurrent threads hitting my service for 1 minute. So, okay, so that's why you see in 30 seconds is the time that it takes. Okay, so it kind of maybe adds up, but I don't know, maybe maybe what I should be looking at here is like right at this point, and then that's what adds up. So the ramp up time is half a minute, which is 30 seconds, which is right about here. Okay, so this is the end of the 5th step. So the ramp up is happening from this point on until this point, and from this to this point we're doing the hold. So for the first 30 seconds we're going to slowly work our way up from 0 number of concurrent users to 160 to 320 to 480 to 640 to eventually 800. So we're taking stepwise. And the question is, why are we doing this? Why not just go straight up to 800? Well, if you look at it, if you actually were to develop this in real life and you were to release, like, say, a typical office application or a typical application, most users don't wake up all at the same time, or most people don't arrive to work all at the same time. Most applications don't see, all of a sudden, when the morning starts, they don't see like the chart going up immediately. What you see is slow ramp up as people come in, as people wake up. They check their social media feeds. So if you were looking at their charts on the infrastructure side, you'd probably see the traffic, sort of following the sunrise timing, right? And then during the day, most people are working, and then you can imagine, like, maybe in the evening, slowly it would, ramp down as well. But we don't have the ramp down here. So the first thing first, this is the BZM concurrency thread group that I'm using, and I'm setting the concurrency maximum to 800, and I'm doing that. I'm asking it to do that in 5 steps. Okay. Now within this thread group, I've asked it to fire off a HTTP request, and the HTTP request is it's coded to call my web page. Now, the service that I've exposed is served on this IP address. If I were to take this and then I just hit it on my, so you can see this is This is the homepage for Nginx, right? And that's what the load test would be hitting as well. And so, you know, we're asking to say, hey, for 800 time, please make this HTTP request at this address. Now, I've sort of hard coded it. I mean, in reality, you're supposed to, you know, put a like a variable here and all of that. But this is just to get the point across, okay? And then once I have that, I am asking it to give me some aggregate results in the table. Yeah, this is I think this is the one. Which one is that? I think it's the result tree that I'm usually very, very interested in. So no, aggregate graph. So aggregate graph is going to tell us that when 800 users come in, what is the average response time? And what is the maximum response time? Okay, so right now the test hasn't been run, so it is initialized to a very low number, which is rather odd. I mean, it should just probably say NA or leave it blank, but that's okay. Maybe some, you know, the room for improvement there, but that's okay. And then some of the things here is active threads over time. As I run the test, you're going to see the same staircase actually bubbling up right in front of you. Excuse me. And then response time is going to tell us this response time report. These are reports, you can think of them. So the response time report is going to tell us how long is it taking for the system to you know, run a HTTP request. Okay. So with that said, let's actually give it a go. Right now, I just want to remind you that how many pods we have running for deploy. So right now the deploy example is only running one pod. So before we hit it with 800, I just want to scale it to at least 2 so that, you know, we have like some sort of a, you know, like a decent chance of getting a baseline number. So right now, if you see, I've scaled my application to 2. So I should have 2 pods called deploy example. So you can see the line, this line over here and this line over here. They're both deploy examples, and I think I'm ready to go. I can also do it slightly differently. Where did we do that? Okay, so there are our 2 parts. Okay, so now we're gonna go ahead and fire off this test. And the way to fire off this test is just to click on this green button, and now the test has started. So what Jmeter is doing is it's waking up and it says, oh, he wants me to create 160 concurrent users and every one of those users should start requesting this Nginx page. Okay, the same page that I went to request when I went to this this thing over here. The same thing Jmeter is doing for us, but it's just doing it so many times. So if you see, this is the chart of transactions per second, and you can see that as time is going by, you will start to see that this chart is going to sort of look like what we requested early on. So maybe this will kind of ring a bell. So let me make it just a little bit thicker so you can easily see the line. Okay. So notice how this staircase chart, by the way, this chart is showing you the active threads that our test suite has created so far. And if you recall, we had asked it to give us 800 concurrent users, and we had asked it to do that in 5 increments, and it has done pretty much the same thing. Now, not exactly the same thing, but very, very close. So this is step number 1, step 2, step 3, step 4, and step 5. And now we asked it to maintain the load for about 60 seconds. So the test should take 1 minute and 30 seconds to run the whole test. Okay, so then it should just ramp down because that's all we told it to do, right? We said, hey, go ahead and, you know, give us 800 threads, but ramp that up in take 30 seconds to get going and stay there for a minute. So 30 seconds plus 1 minute is 1.5 minutes. And after that, nothing else, just done. So now I'm going to show you for these 800 users, how long did the 2 Nginx pod take to reply to us, okay? So if you look at this, the average response time to get that page, the home page, has the average response time of 2,152 milliseconds, which is about, you know, two seconds. Okay, so the total requests that our 800 concurrent users did were about 30,000. So 800 users came and they kept requesting the page for 1 minute. Okay, so during that 1 minute, they were constantly sitting there and requesting the page over and over and over again. So the total samples, the total time the page was requested was about 29,356. I'm just going to say 30,000. Okay, and we're getting a response time of about 2 seconds. Now, 2 seconds is a lot of time. If you feel that the users is going to wait that long, sometimes they do, sometimes they don't. There are some studies that say a blink of a human eye happens in around less than 100 millisecond. And if you make the user wait for more than a second, they start to think about leaving. Now, the maximum response time in our use case was around 23 seconds. Okay, and that's maybe not like great, you know. Let's see if we can spot where that maximum thing came up in the response time chart. Can you look at it and tell me where, where this, let me just make it a little bit, I like to have these lines a little thicker than what they show. So you can see the response time of our system increased at 1 minute and roughly about 20 seconds mark. You see that spike in the response time? Okay, I'm trying to see if I can get the thing to give me the actual data point. I know there's like a way you can just click on it and it'll give you the data point. No? What if I just hover on it? Okay, whatever. It's about it's about 10 seconds. So there, as you can see, there is some room for improvement. We want to stay below 1,000 millisecond, and we want to have less and less of these spikes. Okay, so now with that baseline, the baseline of 2 seconds average and 23 seconds maximum, we're going to try to see if you scale the number of pods and have more pods at our disposal, would the picture change a little bit? So what I'm going to do now is I'm going to scale the number of pods to 10. I'm going to say, hey, you get to have a lot more pods, okay? So now Kubernetes is going to create 8 new pods, and notice container creating is the state. Because Kubernetes has detected that I've asked it to give me 10 copies of deploy example pod, but it only has 2. So the 8 has to be put into the container creating mode. And because our container starts very quickly, pretty soon they're all going to be running, and now they are. Okay. So with that said, I'm going to go back here. I'm going to erase all of these results. Everything goes away. Okay. Now with 10 pods instead of 2 pods, I'm going to, ooh, I don't know if I wanted to do that. Oh. Undo that, please. Undo. What was it? Oh, response time, right? Okay, hang on. Let me see. I need to add this back. Was it the response time I deleted? Yeah, sorry. I didn't want to delete that. I don't know why I deleted it. Okay, so now we're going to rerun the test and we're going to see how long this time it takes, okay? So now we're running the test again. And this time, instead of the service having 2 pods, we now have scaled the deployment to 10 pods, and 800 users are going to come and request that page. You can see in Jmeter, it's actually telling you how many it has right now at this point. Okay, so this is the total concurrency you've requested, and right now it was at 640 when I started the sentence, and now 30 seconds have elapsed, so the system is running at peak load. If you came in over here and you said, you know, I have a command here that I did. Let me see if I can show you the. You can actually sometimes also see this. So if I do Control R, and what was the thing that I did? Top. Okay. Actually, let me just search through my history. Grep top. There was a command that I did. Okay, so if I say, okay, so if I run this command, hey, give me the tell me how each of my pod is doing. It is going to show you that this time, because 800 users are running, the CPU is being used and the memory is being used as well for all of these pods. What am I doing for each of my 10 pods? I'm asking it, please tell me how much CPU is being used. Tell me how much memory is being used. So that's what the system is showing you. And let me see if the test is now completed. Has it completed now? Looks like, yep, we're right at that mark. Okay. And let me see, active threads. Yep, looks like it has scaled down. So if I rerun this command, now that the test is gone, now those 800 users are gone, let's see what our CPU and memory consumption looks like. Okay, I'm not sure why it hasn't gone down. Maybe just give it a little bit of time. Oh, there you go. You see the last one is now kind of reclaimed the CPU. So I don't think I need that much CPU. Let that kind of, sit there for a second. Now, if we scroll back to our results with 10 pods, we see that where is the aggregate? So you remember this was 2 seconds. Now it is 904 milliseconds. So it's gone from 2200 milliseconds to an average of 974 milliseconds. That's less than a second. And the maximum was 23 seconds. Now it has gone down to 10 seconds. And the reason for this is that we have increased the number of pods that can handle the number of calls, which increases the throughput and the response time. Okay, because there are more pods out there, we did that. So this is called horizontal scaling, where you take the same pod of the same size and create more copies of it, and you're able to then see that deployment, scale up and scale down. Now, this was an example of how to scale up, right? You can also, of course, do a scale down by providing less number of replicas. In a future video, we're going to see how we can automate the process of scale up or scale down depending on some external condition, because we don't want a Kubernetes administrator to sit there and issue these commands the way we are doing it here, just to see how the system works, right? Like, you don't want a human to come in here and determine how many replicas are needed and run these commands. You want this to happen automatically, and that automatically means you want somebody to sit there and actually be running this command. By the way, let me run this command one more time, because I want to see if the CPU has gone down or not. Should have. Okay, there you go. Now that there are no users on our pods, everyone is sitting pretty much idle. Okay, but I want this process to be automated. Whenever the CPU is sort of spiking, whenever I'm already under load, I want the system to automatically spin more pods, and that's what we will see next time. Okay, so I'm going to end here. Just as a recap, today we looked at the Kubernetes scaling of the deployments. We talked about the load testing tool. We looked at a few different options, and we then used Jmeter. We downloaded the plugin for running a custom thread group. We used the BZM concurrency thread group to run a 1.5 minute test. We ran this test twice. The first time we ran it with 2 pods, and we saw how long it takes in terms of the min, max, and average. Then we went back and scaled the number of pods to 10. We repeated the test, and we saw that with more pods, we're getting better response times. And that kind of shows us what having more pods does for us. Just as a recap, it's very, very easy for someone to come in here and run this command. I mean, I know we don't want to be running it manually, but let's say if we were running it manually, the command itself to just create more pods and to scale it down is very, very easy, right? This is like a single one-liner command and allows you to do that. Why would you want to scale up? Well, because you want to handle more traffic. You want to,